we have a number line here. So can you find a number between 0 and 100? Well, of course we can. If I divide this 100 into 10 equal parts, I get tens, which is 10, 20, 30, 40, so on till 90. Now, can you find a number between any two consecutive tens? Let's say between 40 and 50. So again, we can divide this into 10 equal parts and we get ones, which is 41, 42, 43 and so on till 49. So now, can I again find a number between any two consecutive ones? Let's say between 42 and 43. Can I find a number? Again, I divide each unit into 10 equal parts and this is what I get. Now I've divided this unit into 10 equal parts. We've seen that this can be represented by fractions, which is 1 by 10, 2 by 10, 3 by 10 and so on. Further, this number here would be 42 plus 1 by 10, which is 42 1 by 10, then 42 2 by 10 and so on. So numbers between two consecutive ones can be represented by mixed numbers. So what we've seen is that this unit distance can be divided into 10 equal parts, which we had represented by fractions. This is 1 by 10, this distance is 2 by 10. So this number here is 42 plus 1 by 10. So this is 42 plus 1 by 10, which can be represented as 42 1 by 10. The mixed number 42 1 by 10. And so on. So we represented these numbers by mixed numbers. Now the problem was, how do we represent these numbers in the place value chart? So where do I put these numbers in place value? How do I represent fractions in my place value chart? So let's look at the decimal system, which is the base 10 number system. What we observe is that the rightmost column is ones, which has a column multiplier of 1. Now as I move towards this side, the next column is 10 times bigger than the previous column, which is 10. Then again we have hundreds, which is 10 times 10, which is 10 times greater than the previous column. Again, thousands is 10 times greater than hundreds. So as we are moving in this direction, we see that we are getting 10 times greater number. Similarly, I can say that on moving towards right, I get 10 times smaller number. From thousands, if I divide 1000 by 10, I get hundreds. Further, if I divide hundreds by tens, I get tens. If I divide 10 by 10, I get ones. Now what I needed was a number less than 1. That is, we had to represent numbers less than 1 by fractions, which we had seen. Now how do I represent that in my chart here? So what I do is, what if I cross this line and go beyond ones? What if I further divide by 10? So what I am doing is, in each case, I am dividing by 10. In each step, I am dividing by 10. Now, what if I go beyond ones? That is, again, if I divide by 10, I would get column multiplier as 1 by 10. And this is what we call as tenths. So we get 1 by 10, which we call as tenths. And we denote this by the symbol, which is small t. So this is how we get tenths. Now the question was, if you have a number, what would the last digit represent? Ones or tenths? Well, to solve this problem, it was decided that tenths would start only after a decimal point. So we put a decimal point, that is a small dot. Now this represents that tenths position will start only after this decimal point. So this is ones, this is tens, this is hundreds, this is thousands, whereas this is tenths. So only after the decimal point, the tens place comes into picture. If there is no decimal point, then we do not have tens place. So let's look at these two numbers now. We have this number without a decimal point. So the last number or the last digit, the rightmost digit becomes ones. And we have a number here which has one decimal point, which has a decimal point. Now, the digit immediately next to the decimal point, immediately right of the decimal point is what we call as tenths. Now, let us try to understand what exactly this tenths indicate. Let us say that we represent ones by this box 1. This is one box. Now if I divide it into 10 equal parts, I get tenths. Observe this decimal point after ones. Now if I color one of these tenths, I get 1 tenths. Now coloring 2 gives me 2 tenths, and so on. Now I can continue doing this only till 9. That is 9 tenths. Because if I have 10 tenths, then that would actually color the entire box and give me 1 ones. So what we see is that 10 tenths is actually equal to 1 ones. Why is that so? We know the column multiplier for tenths. We know the column multiplier for tenths is 1 by 10. So 10 tenths means 10 times 1 by 10, which is equal to 1. Hence that is true. So we've seen, that's what we've just seen, that if you color all the 10 tenths, then you get the entire box which is ones. So this is, now let's come to decimal numbers. So what we can do is, we've seen fractions can be represented by decimal numbers. In fact, any rational number can be represented by a decimal number. So decimal numbers are used to represent rational numbers and put them in our base 10 number system. So rational numbers include both integers and fractions. That means the decimal number that represents a rational number should have both the integer and fractions. So this decimal number in fact has both. This is the integer part and this is the fractional part or the decimal part. So integer plus fraction or decimal, this is what we get. And we've seen how to expand any number in our number system. So let's say we have a number 2085. So this is ones, this is tens, this is hundreds, and this is thousands. So what we do is, when we expand it, the expansion is nothing but the sum of digit with its column multiplier. So 2 times 1000, 2 times 1000, plus 0 times 100, plus 8 times 10, plus 5 times 1. So the digit with its column multiplier. Similarly, we can expand decimal numbers too. Let's look at 2085.4. Now as soon as I have a decimal point, I can say that right column right next to the decimal is tenths. This is ones, tens, hundreds, thousands. Again, so this is the same, similar till 2085 it is the same, which is 2 times 1000 plus 0 times 100 plus 8 times 10 plus 5 times 1. Plus we can add this also similarly. Tens actually imply 1 by 10. Tens is nothing but 1 by 10. So column multiplier for tens is 1 by 10. So similarly I can write 4 times 1 by 10. That is 4 tenths. So that's how I can expand a decimal number. Now how will you expand 0.4, which is 0.4? So in this case this is tenths, this is ones. So this would be 0 into 1 plus 4 into 1 by 10. The digit with its column multiplier. 0 times 1 plus 4 into 1 by 10. Now this is same as 0 plus 4 by 10, which is equal to 4 by 10. So what we get is how to represent this fraction which has base 10 as a decimal number. So 4 by 10 can be written as 0.4. Similarly, you can write 2 by 10 as 0.2, 1 by 10 as 0.1. This was the question, how to represent these fraction numbers as decimals now. So we've got the answer to that. So we had seen on dividing a unit distance into 10 equal parts, we got fractions with base 10. Now these fraction numbers, further these numbers can be represented as mixed numbers. Now we had seen that these fractions can be represented as decimal numbers, which is 0.1, 0.2, 0.3 and so on. So I can replace them by decimal numbers. Further, this is 42 plus 1 by 10, which is 42 plus 0.1. So this is 42.1. And so on, I can have 42.2, 42.3 till 42.9. So now, these integers are 42.0 and 43.0. Now I can replace all these mixed numbers by decimal numbers, which have one digit after the decimal. Now the question is, can I further find a number between any two consecutive decimal numbers, say 42.3, 42.4? I again divide it into 10 equal parts. And this is what I get, 42.3, 42.4. I divide it into 10 equal parts. So now the question is, how do I have decimal numbers to represent this? How will I do that? What I have done basically is, I have divided the 10th distance into 10 equal parts. So what I have done is, I have gone beyond tenths and I have divided this 10th also by 10. So I divided the 10th distance further by 10. So I divided it further by 10. So dividing by 10, I get 1 by 10 times 1 by 10, which is 1 by 100. So dividing 1/10 by 10, I get 1 by 100. That is hundreds. So this is called as hundreds. That is 1 divided into 100 equal parts. So any digit here, and this is represented by this small letter h. So any digit here, now this represents 7 times 1 by 100. This number would be read as 2085.47. Remember that after the decimal point, we read the digits as it is. We do not call this 47. Because this is not ones, this is hundreds. This is 4 tenths plus 7 hundredths. So after the decimal point, we do not read it together. We read the digits separately. So this is 2085.47. And we can expand this number also. We can write this number as 2 times 1000, the digit, sum of digits into its column multiplier. So this is 2 times 1000 plus 0 times 100 plus 8 times 10 plus 5 times 1 plus 4 times 1 by 10 plus 7 times 1 by 100. So this is what I get. So all I've done is, to denote these hundredths, I've added one more decimal place after tenths, which indicates hundredths now. So this is what I had, a number line where I was trying to find numbers between any two consecutive decimal numbers. So between 42.3, 42.4, I divided this 10th distance into 10 equal parts, which gives me hundredths now. So I can represent this as 42.30 and I can represent this number here as 42.40. Now the numbers between them can also be represented by adding just one more decimal place. That is 42.31, 0.32, 0.33 and so on. Further, between these two numbers also, I can find a number by dividing it into 10 equal parts. So dividing 100 into 10 equal parts gives me thousands. I get 3 digits after the decimal. Similarly, numbers between them can be represented by 3 digits after the decimal, which we call as thousands. Now let us try to see what actually ones, tenths, hundreds, thousands actually indicate. So let's say that we have this ones. If I divide it into 10 equal parts, I get tenths. Further, on dividing each 10 into 10 equal parts, I get hundreds. And further, if I divide each hundredth into 10 equal parts, I get thousands. So this is what I get: ones, tens, hundreds, thousands. That is 1. This is 1 divided by 10 equal parts. So this is 1. This is 1 divided into 10 equal parts. Now further I divided each 10 into 10 equal parts. So there are 100 parts in this 1 now. So 1 has been divided into 100 equal parts now, which is hundreds. And further what I did is, I divided this each hundredth into 10 equal parts. So each 100 has 10 parts. So now I have divided this one whole box into 1000 small parts, which gives me 1 by thousands. So this is how I get these numbers. Now I can represent ones by a capital letter O, tens by a small letter t. Remember, after the decimal point, we represent the numbers further ahead, the columns ahead, by small letters, not by capital letters. So I represent this by t, single letter t, this by letter h, this by the first two letters, because t has already been used by tens. So I represent by th, which is thousands. So this is what I get. So these are the first 3 decimal places. So you can continue having more decimal places also, but these are the first 3, that is the tens, hundreds and thousands. Now let us look at this number 1.111. Now this indicates 1 ones, this is ones, this is tens, this is hundreds, this is thousands. Now this indicate 1 ones, that is one whole 1. 1 tens, that is one part out of the 10. 1 hundredth, this is 1 hundredth, one small part. 1 thousandth is this small part. You can see how each digit is adding divisions to the number. So this is 1, 1/10 is further smaller than 1. 1 hundredth is even smaller than 10, which is 10 times smaller than 1/10. 1 thousandth is 10 times smaller than 1 hundredth, which is this small part. Similarly, we can now try to see how we can read 2.649. How would this be seen if I want to represent it by boxes? So I have 2 there, that means 2 ones. Plus I have 6 tens. Plus I have 4 hundredths. Plus I would have 9 thousandths. So 9 of those parts would be colored. So this is equal to 2.649. So what we get is that 2.649. Remember, after the decimal I do not call this 649. This is 649. So 2.649 is 2 times 1 plus 6 times 1 by 10 plus 4 times 1 by 100 plus 9 times 1 by 1000. That is the digit times the column multipliers. This is what we get. Now let's see, let us try to see the same number 2.649 on a number line. Let us see how each digit adds different size dimensions and different size divisions to this number. So we have 2 units plus 6 tenths of a unit plus 4 hundredths of a unit plus 9 thousandths of a unit. So this is what 2.649 is on a number line. So now let's look at the place value chart. So far we've seen from here ones, tens, hundreds, thousand, 10 thousands. Now we've seen we can continue in a similar way even after the decimal point. So after the decimal point I get tenths, which is 1 by 10. Column multiply is 1 by 10 here. Hundreds, which is represented by small h. Thousands, which is represented by th, small. and 10,000s, TTH. Further, you can keep on adding numbers on both the sides. So this is how our place value system holds. Now, reading this number this is 21,509.0374. Remember that these numbers, this is not 374, this is 0.0374. The digits have to be read separately after the decimal point. Now, let's look at this same number with its column multipliers. So 2 is in the column of 10,000s. So the column multiplier for 2 is 10,000. 1 is in thousands, so column multiplier for 1 is thousands. 5 is in hundreds column, so 5 would be multiplied by 100. 0 is in the tens, so multiplied by 10. 9 is in the ones column, so it has to be multiplied by 1. Now after the decimal, you have tenths here. So 0 is in the tenths column here. That is, it has to be multiplied by 1 by 10. 3 is in the hundredths column. That is, it has to be multiplied by 1 by 100. 7 is in the thousands column. Should be multiplied by 1 by thousands. Further, 10,000s. 4 is in the column of 10,000s. So this should be multiplied by 1 by 10,000. So what you say is this number would be 2 times 10,000 plus 1 times 1,000 plus 5 times 100 plus 0 times 10 plus 9 times 1 plus 0 times 1 by 10 plus 3 times 1 by 100 plus 7 times 1 by 1,000 plus 4 times 1 by 10,000. This is how we can even continue with the same thing. Even after the decimal point, we can carry on the same in the same way. In a similar way, we can carry on even after the decimal point. So now can you tell me the place value of 2 in this number? So this is the number here. Place value of 2. We know this is the decimal point. So immediately right next to the decimal point I have tens. This is hundreds. This is thousands. So 2 is in the hundreds column. So place value of 2 is hundreds. Hundreds. So this is how you can find place value of a number. Now decimal numbers can be seen at a lot of places. Next time when you go out of your house or when you in the house also, if you see decimal numbers around, try reading decimal numbers and understanding what decimal numbers represent.